So we're in A2U5L4, and we are going to talk about zeros of polynomials now. All right, first of all, some terminology. The point at which the function intersects the x-axis, that's your zero. That's what we're looking for. So if you have a graph, your x-axis, we only want to find the points where that axis is crossed. We're not worried about the y-axis. A polynomial function of degree n can have at most n real zeros. Now what that means is we've looked at how to tell what degree a polynomial is. That is your highest exponent. So that means that number also tells you the most number of x-axis crosses you're going to have. This lesson is A5U5. This is lesson A2U5L4, and we're going to talk about zeros of polynomials in this. So first of all, what is a zero? Well, a zero is the point at which the function intersects the x-axis. So what that's going to look like on a graph, wherever your graph is, we want to know the points where your graph crosses just the x-axis, not the y, just the x. All right, a polynomial function of degree n. Now you remember how we found degree? That's your highest exponent. Can have at most n real zeros. So whatever that highest exponent is, that's your limit. You can only have that many zeros. All right, if that number is even, then the polynomial has an even number of zeros or none at all. If that number is odd, then your polynomial has an odd number of zeros. Okay, so first let's just examine the graphs of a couple of polynomials and let's see what these zeros look like. Now if you want to graph number one using a chart, just like always you would make your XY chart. So let's say we pick 0 and 1 and -1 and -2. When you fill these numbers in for all three x's, what you're going to get is, if you plug in 0 for all three, you get a 0. If you plug in 1 for all three of them, you get another 0. If you plug in -1 for all three of these, you get a +2. And if you plug in -2 for each one of these, you get another 0. Okay, so look at your exponent here. This is your degree, and what do you see about your zeros? Okay, so let's graph this. I'm going to have a point at 0, 0. I'm going to have a point at 1, 0. I'm going to have a point at -1, 2. And then I'm going to have a point at -2, 0. Now, these are hard to tell all the dips and whatever, so I did go ahead and graph it on Desmos. So this is what it looks like. You can see we got, some of the points, but it's not perfect, like this little dip here. That would be some intensive graphing. That's why we're trying to get away from graphing and get to where we can tell what something's going to do. All right. So now, we want to identify the zeros, all right? So x equals, where does it cross the x-axis? Well, it crosses here at -2, and it crosses here at 0, and then it crosses again at +1. So those are your three zeros. Notice, you get a 0 wherever y is equal to 0. That's where it crosses your x-axis. All right, let's look at another one. Number 2, we've got -x⁴ plus 5x squared minus 4. Now, if I make a chart for it, and I pick the numbers 0, -2, -1, +1, +2. All right, if I plug all these in, I'm going to get a -4. then if I plug -2 into this thing and solve it, that's actually going to give me a 0. If I plug -1 into this polynomial and solve it, I'm going to get a 0. If I put +1 in, it gives me 0, and +2 gives me 0. So what is this going to look like? Well, let's go over to Desmos, and let's see what that graph looks like. There you go. See, it's got 3 little bounces, 2 up at the top and 1 here. So you can see the points that I picked. All right. And if we graph this on hours, just so we can have a look at it, it's going to be 0 to the right or left, down 4. And we're going to have -2, 0, and -1, 0, and +1, 2. So what it graphs like looks something like that. Okay? So what are our zeros? Well, they're wherever y was equal to 0. So it's going to be -2, -1, +1, and 2. And once again, you notice that your degree was 4. How many zeros do you have? Well, it just has to be even, but it is equal to it in that case. Okay, so now let's get to where we are just looking at them and not trying to graph them. First of all, linear factors. The linear factors of a polynomial reveal its 0. Linear factors can be found by writing the polynomial in factored form. So those of you that thought we were through with factoring, well, here it comes again. And the rule is if x minus a is a factor of f of x, then a is a 0 of f of x. Now what that means is if you had x minus 2 times x plus 3 equals 0, and you wanted to find the solution. See, I've got 0 as the answer. Remember, you take each one and you set it equal to 0, and then you solve it down. So what you're going to have here is that x is equal to 2, or x is equal to -3. So your zeros would be at -3 and 2. All right. So that's what we're going to try to do here. We're going to try to factor this, and then that way we can see what the zeros are instead of having to graph it. That would be much simpler. So what do we do when we factor? We look for that greatest common factor first, and there is a greatest common factor of x. So our first step is going to be to take that out, and we're going to get x times x squared minus 2x minus 15. Then we need to factor this trinomial here. All right, this is fine, but we need to get that trinomial factored out, and I see that it does not have, or the coefficient is 1, so that means we're just going to unfold. Now I don't want to lose my x, so I'm going to put it there. I'm looking for a pair of numbers that will multiply to give me -15, but add up to give me -2. So that's going to be +3 times -5, right? So I'm going to have x plus 3, x minus 5. Now, when you solve all of these, first, if you have x equals 0, x plus 3 equals 0, and x minus 5 equals 0, and you don't really have to solve them out because your answers are right here, you know. So, x is equal to 0, x is equal to -3, and x is equal to 5. And you'd want to write that as x equals, and then make that a set, 0, -3, 5. Those are your zeros. And notice we had an odd degree, so we have an odd number of zeros. Okay, let's see what else we can tell. The next word we're going to talk about is multiplicity. Now when you are told that a 0 has multiplicity, that is the number of times that the factor occurs. So in regular words, what that means is if your factored form looks like this, x minus 2 squared, what we say is the 0 of this polynomial is 2, and it has a multiplicity of 2, okay? The 0 is 2, and it has a multiplicity of 2. So let's go to number 4, and we're going to write that in factored form and see if we can identify the zeros. So when we put that in factored form, we get a greatest common factor out first of x. So I have x squared minus 6x plus 9. Okay. Now that trinomial factors into what? X minus 3, x minus 3. You needed a pair of numbers that multiplied to give you positive 9, but added up to give you negative 6. So that's negative 3, negative 3. Okay, so what are my zeros here? Well, the x is equal to 0, so I can put that down. And what's going to happen when I have the two 3's? What this is actually written out as is x times x minus 3 to the second power. That's actually your factored form. So I've got a 3. All right, how many times does the 0 occur? Just once. So that has a multiplicity of 1. The 3 occurs twice. So that has a multiplicity of 2. And that's all it is. You just look for exponents. Now, let's take that same equation, this right here, and we're going to graph it on Desmos and just see what that looked like. Okay? So, I've already got it keyed up. Let me block out the other one. All right. So, let's look at what happened at the zeros. What happened at 0 was it crossed straight through it. And I can graph it if that will help us. We get a point here, and we get a point up at there, 2, 3, 1, 2, 3, 4. Then we have a point here, and then the graph of it does like this. Okay, that's good enough. So let's look at what happens with this. If the multiplicity is odd, so first of all, 0 had a multiplicity that was odd, then the graph crosses at that point. See how it went straight through the 0? It just crossed it. If your multiplicity is even, like the multiplicity of 3 was even, what happened when it got up here to the 3? It bounced, okay? It bounced. So if your multiplicity is odd, it's going to cross through that point. If your multiplicity is even, it's going to bounce at that point. Do you want to go out? Okay, here you go. Okay, let's slide down here and see if we can work some examples now. Number 6 is already given to us in factored form, so all we need to do is find the zeros. Now, if you need to, you can take each one of the factors and you can set it equal to 0, and then you can solve it. So this one is going to be x is equal to negative 7. When you subtract 1 and then divide by 2, this is going to give you x is equal to negative 1/2. And then you got x equals 4 here. So our zeros are negative 7, negative 1/2, and 4. Okay, so what are our multiplicities? Now we got to go back up here to our original to find our multiplicities. We're looking for exponents. So the one that's solved down to be negative 7, it has a multiplicity of 2. The one that's solved down to be negative 1/2, it's only one of them, so it has a multiplicity of 1. And the one that's solved down to be 4, well, that has a multiplicity of 3. So the effect is, remember, if it's even, you're going to get a bounce. If it's odd, you're going to get a cross. So on 1 and 3, it's just going to cross through those points. It's not going to bounce. But at -7, it is going to bounce. Okay, let's look at the next one. And number 7 is not factored for. So the first thing we're going to have to do is factor it. All right, we have a greatest common factor of 2x squared. So let's get that out first. And let's take the -2x squared out. So that's going to leave us with x to the second plus 2x plus 8. And then we need to factor that trinomial. Now I don't want to lose this. All right, when I factor this trinomial, I need a pair of numbers that will multiply to give me 8. We're going to have x and x, plus and plus. I need a pair of numbers that will multiply to give me 8, but add up to give me 2. Okay, now let's look at number 7. Now this one is not factored yet, so first we've got to factor it. And we're going to take out that greatest common factor of -2x squared. All right, when I factor out a -2x squared, this becomes positive x to the second. This plus sign becomes negative now, and then that's going to be a positive 8. All right. Okay, let's look at number 7 now. We're going to have to factor this one first. So let's take out a greatest common factor. Since the leading term is negative, I'm going to factor out a -2x to the second. My lowest power that I have of x is 2. That's why I chose that. Now, when I factor it out, what I'm going to have left is positive x squared. This is going to change to negative because I'm factoring out a minus. So that turns the other two signs are going to change to negative. 2x minus 8. All right, now I don't want to lose this, so I'm just going to write it here. Now with this trinomial, we're going to unfoil it. You know that means 2 sets of parentheses. That minus sign tells you you're going to have x plus and x minus. So I need a pair of numbers that will multiply to give me -8 and add up to give me -2. So that's going to be -4 and +2. Okay. Now, let's pick out our zeros. If you need to set them equal to 0 and solve, you can. But in this first one, right here, what's x going to have to be for 2x squared to be 0? X is 0. All right, in the second set, x plus 2, what's x going to be if you set it equal to 0? Well, that's going to be -2. And then in the third set, if x minus 4 is equal to 0, then x is equal to 4. Okay. So let's look at our multiplicities. Now our first one right here has a multiplicity of 2. This set right here just has a multiplicity of 1. There's only one of them, as does the second one. That multiplicity is 1. So what is going to happen at the 0 point with a multiplicity of 2? It's going to have a bounce. What's going to happen at 1? It's going to cross. And what's going to happen at what's going to happen at Okay, let's look at number 7 now. This one is not factored yet, so the first thing we're going to do is factor it. Since the leading coefficient is negative and there is a common factor of 2x squared all the way through, we're going to factor out a negative 2x squared so that my leading coefficient will now be positive. When I divide 2x squared out of all these things, I'm going to get x squared. It is going to change the signs in there to the opposite of whatever they were. So this is what I have. Now you're going to factor this trinomial right here using the unfold method. So we're going to have an x and an x. Since our second sign is a minus sign, you know you're going to have one of each. Now I need a pair of numbers that will multiply to give me negative 8, but add up to give me negative 2. So that's going to be negative 4, positive 2. All right, so what are my zeros? Well, I'm going to have x is equal to 0 here. This one will be x is equal to negative 2, and this one is equal to positive 4. So I've got zeros at the point where x is equal to 0, x is negative 2, and x is 4. Now let's look at our multiplicities. At the point where x is 0, that's going to be an even one, so our for x is equal to 0, I look back over here, and that had an exponent of 2, so my multiplicity is 2. Then I look over here at x plus 2. That had a multiplicity of 1. X minus 4 also had a multiplicity of 1. Now the effect of that is that a multiplicity of 2 is going to get you a bounce. A multiplicity of 1 is just going to get you a cross. It's just going to go all the way through the point. Okay. All right, now number 8, they want us to write a polynomial function that has a 0 at negative 6 with multiplicity of 2 and 2 with a multiplicity of 1. So what is that going to look like? Now we're kind of having to go backwards. All right, it's going to start off with, well, how do you get negative 6 as a 0? You start with x plus 6, and then multiplicity of 2 is going to mean it's squared. All right, for positive 2, you're going to have x minus 2 and the multiplicity of 1. Now we just need to multiply these things out. And remember, when you have x plus 6 squared, you've got to expand that out to multiply it. All right, so this is what we're going to do. Now we're going to FOIL these first two together. Remember, you can only multiply two things at a time. So when you FOIL, x times x is x squared, and then you're going to get plus 6x plus 6x plus 36, and that's going to be x minus 2. All right, next we're going to combine those two terms. So I have x squared plus 12x minus 36 times x minus 2. All right, now I've got to distribute this into here, or you can distribute whichever way you want to. I just usually distribute the smaller number of terms into the bigger one. So x times x squared is x to the third, and x times 12x is 12x squared, and x times 36 is 36x. Now when I do the minus 2, that's going to give me minus 2x squared and minus 24x and plus 72. Now I need to go back and combine like terms. All right, nothing will combine with x to the third. All right, 12x squared will combine with negative 2x squared to get positive 10x squared. Negative 36 and a negative 24x Okay, let's look at number 8 now. It says a polynomial function has a 0 at negative 6 with multiplicity of 2 and 2 with multiplicity of 1. Write a polynomial function in standard form that could represent this function. So there are probably multiple answers. The easiest way to go is just start with f of x equals. All right, for there to be a 0 at x minus 6, that means you started off with x plus 6, because negative 6 plus 6 would give you 0. And a multiplicity of 2 means that was squared. All right, the 0 at 2 means you started off with x minus 2, and multiplicity of 1 is no exponent. So to put this in standard form, the first thing we're going to need to do is multiply x plus 6 times x plus 6 times x minus 2. Now you can use your perfect square trinomial formula to multiply the two x plus 6's, or you can FOIL it. So when you FOIL, you're going to get x squared plus 6x plus 6x plus 36. And that all has to be times x minus 2. All right, let's combine these two 6x's. So now I have x squared plus 12x plus 36 times x minus 2. Okay, now we need to multiply all the things in the first set times all the things in the second set. So x squared times x, and I don't need that parenthesis, x squared times x is x to the third, and x squared times negative 2 is negative 2x squared. All right, 12x times x is positive 12x squared, and 12x times negative 2 is minus 24x. 36 times x is plus 36x, and 36 times negative 2, or minus 2, is minus 72. Now let's combine matching terms. Nothing will match the x to the third. All right, I have negative 2x squared plus 12x squared, so that's going to give me positive 10x squared. And then negative 24x plus negative 36x is going to give me positive 12x and then minus 72. Okay, and that is actually going to be the answer in standard form. Okay, so this was a fairly short lesson this time. I want you to go to your practice pages and be using your extra time to work on these examples and ask me any questions if you have them.